Welcome viewers, in this video I will see the details about 4:1 multiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the 4:1 multiplexer. So generally the multiplexer is nothing but 2 to the power n is to 1. That is 2 to the power n input and having only one output in that n selection lines. This selection line will decide which input should be available at the output, right? So the multiplexer is nothing but many input into one output decided by the selection lines. So in this the n equal to 2, 2 to the power 2 is to 1, that is 4:1, having two selection lines, right? So the 4 inputs are available, only one output, that 4 input is decided by the two selection lines. The diagram shows the 4:1 multiplexer. Each of the 4 lines D0 to D3, right? The 4 lines are D0 to D3 is applied to one input of an AND gate. We are using AND gate. Selection lines are decoded to select the particular AND gate, right? The selection is done by the selection line, that is decoded by the selection line. Here we are using the AND gate. Now we'll go to the logic diagram. So we have 4 inputs, only one output and 2 selection lines, right? So we are using the 4 AND gates. These are added by the one OR gate. The input to the first AND gate is D0, second AND gate is D1, third AND gate is D2 and fourth one is D3, right? So the 4 inputs are given to the 4 AND gates, right? Then there we have the selection line is available. The selection line is available S0 and S1, right? S0 and S1, the selection line S0 and S1. By connecting one NOT gate, we got S0 dash. Here also in S1, by connecting one AND gate, one NOT gate, we got S1 dash, right? So we have S0, S1 as well as S0 dash and S1 dash, right? So this is selection line, selection input S0, S1. By tapping is taken and connected to the NOT gate, so with that we got S0 dash. In S1 also the tapping is taken and connected to the NOT gate, so that we got S1 dash, right? So S1, S0, S1 dash, S0 dash is available, and also enable input is available. If enable input is 1, then only this circuit will work. If enable input is 0, the circuit will not work. In order to control, we have enable input, right? Now we need to connect this either S1 or S2 or S1 dash or S0 to the particular NOT gate, right? How will you connect this? We have the processes available, right? So there are 2 selection line means there are 2 selection lines, so we have 4 combinations are available, right? So this 4 combination, out of 4 combination we have 0 0 0 1 1 0 1 1. There are 4 combinations are available. So the 0 0 is connected, that is S1 dash and S0 dash is connected here. So this is the enable input. Enable input is connected to all the NOT gate, all the AND gate. So these two are the selection line. So the first AND gate S1 dash and S0 dash is connected. For the second AND gate S1 dash and S0, that is 0 1. This is 0 0. This is 0 1 is connected. For the third NOT gate S1 and S0 is connected, that is 1 0. For the fourth AND gate S1 and S0 is connected, that is 1 1. See, so the bar, the complement refers, it is 0 0 0 0 1 1 0 1 1. So because of 2 input lines, 2 selection lines, there are 4 combinations are available. These 4 combinations are connected to the AND gate. So the AND gate having 4 inputs. One is the data line, second is the second is the enable line, third and fourth is the selection lines. These selection lines are connected according to the combination 0 0 0 1 1 0 1 1, right? So based on that it is connected, all are connected to that, to the OR gate, so that it will add all this and will produce the single output, right. Now we'll see what will happen if it is 0 0, if it is 0 1, right. So already discussed, there are 4 selection lines are there. So 0 0 0 1 1 0 1 1, there are 4 combinations, right. First we will see 0 0. If it is the S1 is 0 and S0 also 0, what will happen here? S1 is 0 and S0 is 0 means S1 is 0 means S1 dash will be 1. S0 is 0 means S0 dash will be 1. Already enable input also 1, right. So the D0 all are 1. So the D0 will be available at the output, right. The D0 is 0, 0 will be available, D0 is 1, 1 will be available at the output, because in AND gate 3 inputs are 0. So the third input automatically available at the output. See here, so what we have, it is 0 0, right. So this input is 0, S0 is 0. So totally this NOT gate will be, this AND gate will not produce any output. Similarly here also this is 0, we have 0 0, this is 0, this is 1. So this input, this AND gate also will produce 0. Here S1 S0 both are 0 0 only. If any input is 0, the AND gate will not produce any output, right. For 0 0 combination, only this NOT gate, all the inputs are 1, so it will produce D0. Other AND gates, any one of the input is 0, so automatically it will produce only 0 as the output, right. So for 0 0, D0 is produced, D0 is available at the output, right. Now we'll go to 0 1, right. If the S0 is 0 and S1 is 1. S0 is 0 means S0 is 0 means the 0 will be available. If S1 is 0 means S1 bar will be 1. Already enable input also 1. So that D1 will be available at the output, right. So second combination is 0 1. S1 is 0, S0 is 1. So here S0 is available, S0 is 1. But here S1 dash is available. S1 is 0, so S1 dash will be 1. Enable input already 1. So all are 1 only. So the D1 will be available at the output, right. So according to the combination only the selection lines are connected. The remaining AND gates automatically become 0, right. Now we'll go to the third combination, 1 0, right. 1 0. S0 is 0, S1 is 1. S0 is 0 means S0 bar will be 1. S1 is 1. Already enable also 1. See, these all are 1. So that D2 will be available at the output. This is connected to OR gate. So OR gate will produce D2. The other terms are automatically 0. For example, see here 1 0. S1 is 1, S0 is 0. 0 means totally it is 0. Similarly, these also become 0. I will go to the fourth one, 1 1. S1 is 1, S0 also 1. Already enable is 1. So that 3 inputs are 1. So automatically it will produce D3 as a output, right. So based on this, the selection lines are connected, either connected S1 or S1 bar or S0 or S0 bar, so that we are getting the particular input, right. For 0 0, we got D0 as a output. 0 1, D1 is as a output. For 1 0, D2 is as output. For 1 1, D3 as a output, right. How we got 0 0 D? How we got for 0 0 D0 is output? For 0 0, we are connecting S1 dash and S0 dash. So 0 0 means automatically it become 1 1 because we will taking complement. Similarly, 0 1 means S1 is have S1 bar. So 0, S1 is 0 means S1 bar become automatically 1. Similarly, 1 0, S0 is 0 means we are connected here S0 bar. So that 1 0 means automatically it become 1 1. Similarly, here both are already 1, here directly connected, right. So based on the combination, we got any one input as a output, either D0, D1, D2 or D3. Right. So this is the logic diagram. We are having 4 AND gates, all are connected by the OR gate in order to produce the output. This AND gate, one input is data, second input is enable, third and fourth input is selection lines. These selection lines are connected in such a way that according to this combination 0 0 0 1 1 0 1 1. 0 0 means it is connected with the complement. So while 0 0 it become automatically 1, so that it will produce D naught as a output. So accordingly it is connected. Now we'll go to the truth table and block diagram. So in this truth table, if enable is not available, if the circuit is not available, whatever may be the selection line, the output is 0. Enable is not there mean output will be 0. If enable is 1, then only it will produce the output. Right. For that 4 combinations are available. Already we discussed. 0 0 means it will produce D naught. 0 1 means it will produce D1. 1 0 means it will produce D2. 1 1 means it will produce D3. Right. So what we discussed, it is given as a truth table. So this is the block diagram. There are 4 inputs are available 0 1 2 3 D naught, D1, D2, D3. One enable input and 2 selection lines S1 and S0. So based on the selection line, either D0 or D1 or D2 or D3 available at the output. Out of 4, only one output is available. Out of 4 input, one is available at the output, that is decided by the selection line. So the description is available. We will see the description for one particular case. For example, when S1 and S0 equal to 0 1, S1 is 0, S0 is 1 mean the AND gate associated with the data D1 has 2 of its input is equal to 1 and third input is connected to D1. Right. The 2 of input means we have S1 bar and S0, so that the 0 become 1. This is already 1. We have already one enable is there. So 3 inputs are 1, so that the D0 will be D1 will be available. And other 3 AND gate having at least one input is equal to 0. Right. And one of the input is 0, so that which make the output is equal to 0. Right. Here 0 is there, but we are connected S1 bar, so that 0 become 1. So all 3 input become 1 and D1 is available. But in other 3 gates, any one of the input is 0, so the totally the output will be 0. The OR gate output is now equal to the D1. Right. All 3 AND gates are 0, only the first AND gate will produce D1. So D1 plus 0, totally we have D1. Thus we can say data bit D1 is routed to the output when S1 and S0 equal to 0 1. What we discussed, the description is given. Similarly, we can analyze for other 3 cases also. So in this video we discuss about the 4:1 multiplexer. 4 inputs, 1 output and 2 selection line. How these 4 inputs are routed to the output. One of the output is decided by the selection line. We discussed the logic diagram, block diagram and truth table. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.